Hello everyone. In this presentation, I want to talk about China and Taiwan. I want to talk about the history of China and Taiwan, and I want to do an analysis on why they are most likely to fight next year in 2027. The information I'm going to talk about is what I've read and watched. The information could be wrong or right. That's why I want you guys to question what I will talk about and do your own research to come to your own conclusion. This is a map of China. Quick facts: China is also known as the People's Republic of China (PRC). It is a one-party state ruled by the Chinese Communist Party (CCP). According to Worldometer, the population is 1,413,238,043 people. China has a very rich history and culture spanning thousands of years. China has been ruled by various dynasties such as the Han, Tang, Song, Ming, Qing, to name some examples. China has contributed so much to human history and culture. The four great inventions, papermaking, the compass, gunpowder, and printing, are Chinese. This is one example of what China has contributed. This is a map of Taiwan. Quick facts: Taiwan is also known as the Republic of China (ROC). It is a democracy with multiple political parties allowed to govern Taiwan if they win an election. It is a two-party state currently ruled by the Democratic Progressive Party (DPP). The other party that has ruled Taiwan is the Kuomintang (KMT). According to Worldometer, the population is 23,021,023 people. This picture shows the out of Africa theory. According to this theory, we humans originated in Africa, then we started to spread out across the world. This presentation is about China and Taiwan, so we will focus only on them. It is believed that humans first arrived in China about 45,000 years ago. There's an archaeological site in China called Shiyu. A team co-led by Francesco Derico at the University of Bordeaux in France re-examined an archaeological site called Shiyu in northern China. They published their findings in the Nature, Ecology and Evolution journal. It was originally excavated in 1963 during the early years of China's Cultural Revolution. Derico said that it was not the best time to find such an important site. You can see the Shiyu archaeological site on the left and Francesca Derico on the right. I will explain what he meant later on in my presentation. Shu is an open-air site in a river gully. It holds a 30-meter deep deposit of sands and other sediment, which the original excavators divided into four horizontal layers, the second from bottom of which was found to hold evidence of human occupation. The excavators found over 15,000 stone artifacts and thousands of animal bones. There was also a single piece of hominin skull, which anthropologist Wu Kang identified as a modern human, Homo sapiens. Some of the artifacts were transferred to the Institute of Vertebrate Paleontology and Paleoanthropology in Beijing, but those left at the local facilities, including the hominin bone, were lost. Derricker and his colleagues re-excavated Shuyu to determine its age. They dated 15 samples of sediment using a technique called optically stimulated luminescence and carbon dated 10 animal bones and teeth. The hominin layer is about 44,600 years old. Derrico was confident that the skull was correctly identified, as according to him, the excavators were knowledgeable. The Shuyu hominins were probably Homo sapiens, said Arina Katsanovich at the Institute of Archaeology and Ethnography in Novosibirsk, Russia, who was not involved in the study. As such, this new study implies modern humans had reached northern China about 45,000 years ago. This pushes back human arrival in China by about 5,000 years. Archaeology is the study of human history and prehistory through the excavation and analysis of material remains, providing insights into past civilizations and cultures. Every great civilization leaves something behind. This could be anything: structures, artifacts, remains. Archaeologists usually have to excavate areas because often the material remains are often buried deep within. Excavating means removing earth, rock, and other materials from a site to access the material remains. The picture on the left shows some archaeologists excavating a site. The picture on the right shows some artifacts removed from a site. Archaeologists use several techniques to assist them. Geophysics lets us see underground without digging. Tools like ground-penetrating radar, magnetometers, and resistance meters are used to scan the soil and create digital maps. These maps show walls, buildings, or other features hidden beneath the surface. LIDAR, like detection and ranging, uses laser scanning from aircraft to create 3D maps of the landscape, including areas hidden beneath trees. The picture on the left shows ground-penetrating radar. The picture on the right shows LIDAR. Radiocarbon dating measures the decay of carbon-14 in organic materials such as wood, bone, or textiles to determine age, effective to about 50,000 to 60,000 years. Carbon is an element. An element is made entirely from one type of atom. Atoms are the building blocks of life. Most things are made up of atoms. Everyday objects that we use are made up of atoms. Atoms contain protons, neutrons, and electrons. Isotopes are different forms of the same element. They have the same number of protons and electrons, but different number of neutrons. Carbon has 15 known isotopes. Carbon-14 is a rare radioactive isotope of carbon, containing 6 protons and 8 neutrons. It is continuously created in the upper atmosphere by cosmic rays. Cosmic ray neutrons collide with nitrogen-14 in the atmosphere, transferring it into carbon-14. This combines with oxygen to form radioactive carbon dioxide. Plants absorb this carbon dioxide through photosynthesis, and it passes up the food chain to animals and humans. As long as an organism is alive, its level of carbon-14 remains constant. When an organism dies, new carbon-14 is not taken in, and the existing carbon-14 steadily decays back into nitrogen. Carbon-14 begins to decay at a known rate, with a half-life of approximately 5,730 years. After 5,730 years, half of the carbon-14 in a sample is gone. After another 5,730 years, half of the remaining carbon-14 is gone as well. Scientists use accelerator mass spectrometry to count the exact remaining atoms and calculate the time elapsed since death. Dendrochronology is a scientific method of dating growth rings in trees to the exact year they formed. By comparing ring patterns from different trees and overlapping their timelines, scientists create an extended chronological record. Tree rings or growth rings are annual records of a tree's life in environmental conditions. In regions with seasonal climate variations, this growth results in distinct rings, each representing 1 year of a tree's life. Archaeologists can use dendrochronology to precisely date the felling time of wooden beams in ancient structures and artifacts. Felling is a process of cutting down a standing tree. Early humans in every continent were hunter-gatherers. They would live in hunter-gatherer communities. Every day they would wander around and hunt for the food. The picture shows some humans trying to hunt an animal. They didn't practice agriculture. Hunter-gatherers would hunt animals and gather edible plants. Communities moved as the seasons changed to follow animal migrations. Humans did this for tens of thousands of years. After thousands and thousands of years of hunting and gathering, why did some groups of people start domesticating animals and plants and practicing agriculture? Agriculture is the cultivation of soil, planting of crops, raising of livestock, and processing of resulting products for food and fiber. One of the earliest attempts to answer the question why humans started to practice agriculture was made by V. Gordon Childe, an Australian archaeologist. He suggested that environmental changes at the end of the Pleistocene were the impetus for food production. Child argued that about 10,000 years ago, the climate in parts of West Asia became drier due to a northward shift of the summer rains. This drying up led to a concentration of people, plants, and animals close to water resources, such as rivers and oases. This enforced closeness eventually led to new relationships between humans, plants, and animals in domestication. Child's theory was questioned by Robert J. Braidwood, an American archaeologist, who rejected the focus on environmental changes as the crucial factor leading to agriculture. He pointed out that environmental changes had occurred within the Pleistocene as well and had not led to agriculture. The Pleistocene is was the geological epoch that lasted approximately 2.58 million to 11,700 years ago. It is defined by repeated global glaciations, ice ages, and the evolution of modern humans. A geological epoch is a unit of time used by scientists to divide Earth's 4.6 billion year history into manageable chunks. This is a representation of time based on the rock record of Earth. Braidwood argued that domestication took place in certain nuclear zones, which supported a variety of wild plants and animals that had the potential for domestication. In such areas, domestication was the natural outcome of human experimentation and people getting to know their environment better. This theory doesn't explain the pressures or incentives that may have led to domestication. There's ethnographic evidence of many hunter-gatherer groups who understand their environment intimately, yet do not see the practical benefit of relying on that lifestyle themselves. There have to be good reasons for a community to radically change its way of life. Braidwood's theory was rejected by Lewis R. Binford, another American archaeologist, on the grounds that it could not be archaeologically tested, and there are some specific concrete factors that can explain the beginnings of agriculture. Binford asserted that ethnographic evidence indicates that in areas where environment and population remain constant, a stable balance between human population and food resources is achieved, and people do not have to look for new sources or strategies to get food. Such groups in fact tend to live at food consumption levels far below the resource potential of the environment. Ethnographic evidence comes from ethnography. Ethnography is studying cultures and social practices through immersive observation and participation. Two factors can upset the balance between people and food: stress produced by environmental changes or by demographic population growth. Binford identified two kinds of demographic stress: internal demographic stress, which occurs when the number of people within a community increase, and external demographic stress, caused by immigration into an area by people from another area. In the context of the origins of agriculture, Binford emphasized external demographic stress. He argued that at the end of the Pleistocene era, as a result of a rise in sea levels, people living along the coast migrated to less populated inland areas. This upset the people-food equilibrium in inland areas and gave an impetus to the search for new strategies to increase food supplies. The problem is that evidence of a migration of people from the world's sea coast to inland areas at the end of the Pleistocene is lacking. Internal demographic stress may have been a factor in upsetting the people-food balance, but a question that can be raised is, can we really talk about population and food crisis in times when human communities were small and resources abundant? Recent studies have suggested that the key may in fact lie in environmental change, though not suggested by a child. In many parts of the world, the Holocene was marked by the onset of a milder, warmer, and wetter climate. The Holocene is the current geological epoch, beginning approximately 11,700 years ago. Such changes may have led to an expansion of the natural habitat of wild cereals that had the potential for domestication. Given the limitations of the evidence and the fact that we are looking at very slow, gradual processes that must have varied in pace and detail, we may never be able to fully comprehend the details of the processes of animal and plant domestication or identify the impulses that lay behind them. It should also be remembered that in the case of complex cultural processes, the archaeological evidence often provides little hard data on social and political factors. More important than isolating a single factor responsible for the origins of domestication is to try to track down the process as it unfolded in different regions. Given the variety in ecology and resources in the various centers of early plant and animal domestication, it is very possible that different factors may have been involved in different parts of the world. The picture on the left shows the planting of wheat. The picture on the right shows a farmer raising livestock. The man on the left was V. Gordon Child, an Australian archaeologist. The man in the middle was Robert J. Braidwood, an American archaeologist. The man on the right was Lewis R. Binford, another American archaeologist. So I'm going to end this video here. If you enjoyed this video, don't forget to press the like button. Leave your comments down below. Correct me if any of my information was wrong. Share your own insights into what I spoke about. If you haven't subscribed, please do, and press the bell icon so you will be notified whenever I upload a new video. I will see you guys in the next video.